Welcome to qnawire.
Alright, let's go ahead and solve this problem. So we're given a vector f negative 2yz, comma y, comma 3x, and the surface is the paraboloid. Z is equal to 5 minus x squared minus y squared. I just wrote it like this because it's usually going to be more convenient later. And z is above 1 is how it's stated, but from the expression we know that z is going to be between 1 and 5. So it is going to be forming a cap with a bottom lid which is a plane or a disk at a height 1. Okay. All right, so we want to confirm Stokes theorem again. So we are going to have two approaches. One is to take a look at the region C, which is the boundary of the circle right here. X squared plus y squared is equal to um, 2. Is it 2? Let me double check. We know that the radius is 2. Yeah, so the radius is going to be 2. And we're going to parameterize C as this. We know that the angle is going to be useful, theta, and then I will say that x is equal to cosine, y is equal to sine. Now z is constant, it's at 1, so we know that this is equal to 1. Okay, from here we just need to take the derivative. Oh, sorry, the radius is actually 2, so I need my 2's there. X is equal to 2 cosine, y is equal to 2 sine. And we take the derivative with respect to theta. So r sub theta, it is equal to negative 2 sine, comma 2 cosine. Derivative of 1 is 0. Let's put f in terms of theta. It will be negative 4 sine theta, 2 sine theta, and 6 cosine theta. Now we take the dot product, f dot r. Okay, so you will have 8 sine squared plus 4 sine theta cosine theta is what you will get, but I like to put that as 2 sine of 2 theta. Because sine of 2 theta is equal to 2 sine theta cosine theta. Okay, so what we're trying to evaluate here is through C, we have 8 sine squared theta plus 2 sine of 2 theta d theta, and the angle varies from 0 to 2 pi because it's one revolution. This is a straightforward integration, so we will get 8 pi. I want you to do the calculation on your own. So the other integral, the double integral here, we're supposed to get 8 pi as well. So let's see if that is going to be the case. So first I will calculate the curl. I've already done the calculation. However, you will get 0, comma, negative 2y minus 3, comma, 2z. All right, now I will choose the parameterization of the surface S. Let's actually make it clear that I am using two parameters, r of rho, comma, theta. There you go. So x, I choose rho cosine, rho sine for the y. And for z, we know that it is equal to 5 minus the sum of x squared plus y squared. We know that x squared plus y squared according to these choices of the parameters, we're going to get our rho squared. So we will get 5 minus rho squared. Okay, let's take the partial derivatives. With respect to rho, we will get cosine, comma sine, comma negative 2 rho. With respect to theta, we will get negative rho sine, comma rho cosine, negative 2 rho. Oh, this one is actually 0. Excuse me. There you go. We will take the the cross product because we want the normal vector. It comes out quite nicely. It is going to end up being 2 rho squared cosine theta, comma 2 rho squared sine theta, and the last one it is going to be rho. All right, curl F, I am going to rewrite it in terms of rho and theta. 0 is 0. Y is rho sine theta, so you will get negative 2 rho sine theta. 3 is just 3. And z is 5 minus rho squared, so you will get 10 minus 2 rho squared. Now we're going to take the dot product of these things. This one does not end up being a really nice expression, even though the I portion of it becomes 0, but there's a binomial, there are terms with rho cubes and rho squares and rows. When you simplify it, or at least when I simplify it, I like to write it like this, negative 2 rho cubed. I can factor that out from 2 of the terms. You will get 2 rho, oh, I don't have a rho. It's actually 2 sine theta. Is it squared? Yes, it is. Plus 1. You have a rho squared term plus 6 rho squared sine theta. Let me move this a little bit more to the left so that we can see it. I don't need to move all of that. Hold on. Does this work? That's good enough. There you go. One more term. We have plus 10 rho. Okay, so the double integral that we need to get is the theta varies from 0 to 2 pi. It's one entire revolution. Rho, it starts from here at the center, radius 0, and it goes all the way to radius 2. So it's from 0 to 2. And it's just the expression that we got right here. Let me call that A, just for simplicity, saving space. And d rho d theta. Okay. Now, this one takes a little bit longer, but still it's quite a straightforward calculation because rows are just polynomials and sines, you do have a sine squared, but let's recall that sine squared theta is equal to 1/2 1 minus cosine of 2 theta, so it shouldn't be that difficult of an integral to calculate by hand. And of course, you can use a calculator in order to calculate this as well, but you will get 8 pi. Okay, so because we get these two numbers to be the same, it basically confirms the fact that the Stokes theorem is true. And that's how you